So, good evening, everybody.
Good evening, sir. You are loud and clear.
Okay, thank you. Thank you for the information. Let me start now. So, in this session, we'll be talking about Pytorch. I request Dr. Zakir to share the Google Drive with the participant, Google Drive link. Shall I proceed, Afsar?
Yes, sir. The link has been posted for everyone and even in the WhatsApp group also.
Okay,
You can start,
thanks.
sir.
Thanks a lot. So, let me share my screen first. Okay, something about our Google Meet. In Google Meet, this is a special Google Meet that we have purchased for this workshop. Here, there is a separate activity tab. In this activity tab, can you see my screen right? In this
Yes, sir. Yes, sir.
in this activity tab, you can have a separate Q&A, and then we can take up the questions one after another that will come up. Okay, so please I request you to prefer this, so that when we can type answers or something take up, it will be easy to take up and we'll know the better way to organize it. Okay, so please use this facility. Second thing, most of the sessions we will be using basically coding or the view. If you see my current view is very cluttered. A lot of users are being shown. My actual area which I need to look is very small. So you can do your own housekeeping, and by changing the layout, you can just select on Spotlight. It will show you only the shared version. Okay, and remove the unnecessary clutter. Fine. Then third thing, if you have anything, you can raise your question, raise your hand, or you can ask the questions and keep the session interactive. Okay, fine. Thank you. So if you are looking this screen very small, then you can even use F11 and make your screen full, like I have done it. Okay. So like this, you can organize your own screen without an interruption from anybody else. Okay. So hope you will make utilize these facilities better. Right now, I'm going to start with Pytorch. Okay. So this is a home for Pytorch library. Pytorch was earlier started by a particular company, but now it is totally open source. It is a Pytorch Foundation that is being managing this all right now. It's not under any company. Earlier, TensorFlow and Pytorch, like you see, were coming from Meta and Google respectively, and there was a lot of uh, uh, conflict of interest. That conflict of interest is resolved by making it as an foundation or the NGO. So anybody can be part of this community and can start using it. Okay. So when we start locally, basically what we need to do, we can select here. If you have only CPU, no CUDA available, this is the command that you have to use. You have to use and install your PyTorch in your local machine if you don't have the GPU. If you have the GPU, you need to select which CUDA version you are using, and based on that, you need to select the appropriate CUDA version that is being installed on your system, and then use this command for the installation. Here, some glitch may be pip3. Pip3 and pip are two different package managers. Pip3 is an advanced package manager, and pip is the old package manager. So if you are not installed pip 3, it may give an error. By default, most of the Anaconda will come with pip. Okay, so are you clear with this? So do you find this housekeeping announcement on keeping your screen clear is useful? Yes, no? Uh, I cannot find any responses. Okay, Saifuddin has asked some question. Raised the hand. May I know what is an issue? Sir, can you check with Saifuddin what is an issue?
Mr. Saifuddin, you can unmute yourself and ask the question if required, or you can post the question in the question answer section.
Okay, so can I proceed now? If we install this, depending upon your internet capacity, depending upon your hardware, it may take several hours to install. Okay, on your local machine. I don't know how many of you have went through the installation and successfully done it. I was expecting some issues discussion in our group. Unfortunately, I didn't find any such thing. But feel free to ask any problem that you are encountering. One thing should be clear: we are trying to accommodate. Every session is like one full course. It is full course. We want to give you the complete package of an computer vision engineer in this just 12 sessions. So which is very hard to do until and unless you cooperate and deep dive yourself. That's why we have shared with you our cute embedded AI lab GitHub, which was tailored very systematically by training over 200 participants in last 2 years. All of them have been professionally trained. Some workshops were even for 1 month, and the shortest workshop was like 1 week, but whole day, not like 2 sessions. So like 6 hours sessions. So we had the hands-on. So in this process, what I would like you to go through is, please keep in mind, we are trying to help you to learn further. So in our embedded AI GitHub, if you go through it, you can find enough material for doing everything. And we are also providing you containerized content again for the this workshop also. Okay, so please try to understand there are two ways. You will spend a lot of time in learning, or you learn the enough to start doing. If you learn enough and start doing, you will learn more gradually. Until and unless you have this requirement, like you are searching a job based on a AI programmer or computer vision programmer, right now you don't require a certificate. If you are from an academic background, if you get a right pointer and start, you can start developing the throughput. Means you can produce papers, you can comprehend the research, and you can contribute to the community. So take one project, be a part of one special group. From this 200 participants, we need to have certain specialized group focusing on each area. Okay, and then we need to proceed further. So here what I recommend for a deep dive is this book. This book is already I've shared in my Google Drive as an PDF, and you can go through this book as and when required. So you decide your project first, or the task to be learned, then take the GitHub code, then start running that code. That should be the modality. And when you try to modify it and try to change, you require this knowledge what we are giving you right now. And in that course you will learn so many things that are going to be a professional code. The second famous book is Deep Learning MIT Press book. This is a foundational book with lot of background mathematics. This is also given in a Google Drive link. Okay, so this is a PyTorch installation from where we need to get a start. We can install the PyTorch on a only CPU machine, but will not be able to run heavy models or train the models which have very heavy or beyond the capacity of CPU. The simple thing will be, at least it will slow down significantly. If you are doing the video analytics, your fps will be slashed 10 times to 100 times. Okay, if you are doing the inference, if you are trying to train, it will take infinite time, means lifetime, to complete the training, which is not feasible for doing the real world project or the actual research. But definitely you can test your code concept, whether it works or not. Then you can push your code to the Google Colab, Kaggle, or Paper Space Gradient, and then move on. Is this clear? So right now, the Google Colab, which I have created for today's session, let's move to that. Okay, so these are the things that I have provided to you in day 2, session 2. I cannot cover all of them, but I will cover the major fundamental things. Okay, so here you can see this is a textbook which I have discussed, the first textbook, which I have shown you on the link also. This is the second textbook, and these are the some elementary notes from Stanford Computer Vision course 2017. Basically, lecture 2 is based on image classification, and lecture 5 is on convolution network or CNN. So most of the time, uh, uh, the deep learning models that we are using will be CNN. The futuristic computer vision models will be also based on vision transformers. So in this course, directly we are not dealing with computer vision transformers or vision transformers, but we will explain you how to start and reach to that. So let me start with uh, first thing first. So computer vision is the art of teaching a computer to visualize its surrounding. Means giving a machine to power to see the world. It was easy for a 3 years kid to identify cat and a dog, but computers were not able to do that successfully in an unconstrained environment for long, until the deep learning technique called CNN was developed. That's why we are going to put an emphasis on CNNs. So when we identify what is this in a given picture, a main object, then we call it a classification. Okay. So basically there are two types of task: classification and regression. Classification and regression. So what is classification? What is this? If you can answer, this is a cat, this is a dog, this is a thumbs up, this is thumbs down, then this is a classification. If you can identify where is the nose of the cat or the eyes of the cat, means you require an xy coordinate of the center point of your eye of the cat, then this is called regression. So these are two different tasks. When we combine these two tasks, we basically develop an detection model. Okay. In detection model, we provide a loose boundary. We provide a loose boundary. Excuse me, just a minute. I think I got some typo here. Okay, not an issue. So here basically when we go for classification and regression, let me use the PPT for a while. So if I can identify this is a Louis or not a Louis, I will call it this as a classification. Okay, if I specifically ask for a particular aspect in the what do you say particular point of the image, then this we call is regression. When we combine these points and the classification, then we call it detection. I hope the slide is visible to you. So you can see if I can call this is a person, then this is a classification. If I say these are the eyes, the XY coordinates of the center or the multiple points or face outline, whatever, these points are called regression. So basically, when this result is generated by a detector as a face, it will identify this as a face, and it also identifies XY location. XY location, either center of the box or the XY location of the upper left hand corner, depending upon the type of the detector used. Okay, so these are the two major things. The third thing that we use is called segmentation. In what is the difference between detection and segmentation is, see the face, many of the pixels in this face are not from the face. Can you see in this bounding box? There are certain pixels which are background behind the head. There are certain pixels. Excuse me. Are you able to listen to me?
Yes,
Hello.
sir.
Okay. Thank you. So exactly identifying the boundary of the face is called segmentation. Identifying what this is called semantic segmentation. Okay, so these are the general tasks that we will be uh, taking care of in our course. Okay, so now what we are going to cover in a PyTorch, basically don't focus much on PyTorch. Look at this image. Okay, how many boxes you see or the steps you see in this image? 6, right? What is the first one? Getting the data ready. Means bringing your data, whether it's a supervised learning, unsupervised learning, whatever form of learning. If you want to train your model, yesterday I told you that we require a data. Okay, sometimes we require the label with them. This is called supervised learning. Suppose if I provide a image saying that this image is of a cat, then that is called labeled image. And you can apply any supervised algorithm, or you can develop an AI model which is being developed based on the supervised algorithm. So what you require? A data. Okay, if it is a supervised algorithm, then it should be a data with labels. Okay, so this is a first step that you can get the data ready. So there are certain data sets which are already standard for the development of the deep learning field. Those data sets have been matured as an example toy programs or toy data sets. one of the most important data set which brought the uh, revolution on deep learning was ImageNet dataset. So this was the dataset which has created the major breakthrough in the deep learning field. Okay, so this dataset had certain okay had certain images which have been released as a challenge from the Sanford. Then the CNNs which have performing better on this CNN, this became the major backbone architectures in deep learning. So we call them what you say ImageNet models. Okay. So ImageNet dataset was having the 1,000 objects and totally around 1.2 million images. And this challenge was issued around 2011-12, and then so on. The competition was conducted, and most of the popular data models or AI models in CNN comes from ImageNet architecture, developed during the ImageNet competition. Okay. So you can pick or build any model. You can have a pre-trained model, or you can pick any or build any new model. So if you have a pre-trained model, means already that model is trained on ImageNet or some other data set, then you will use it for you will freeze the lower layers. You will not train them because you have very small data set. You will train only the upper layers. For example, you have 10 layers in your so assume this each image that you see is an output of one layer. Okay, and this is one CNN architecture. When I feed this image, what happens in layer 1, 2, 3 is being shown here. Uh, Basically, the first layer is a convolution layer, second layer is a pooling layer. Sorry, activation function or a ReLU. Okay, like that, the layers have been arranged, and finally, you can see from this image, we are able to see that this is majorly predicted as a horse. But you have been given top 5 predictions because this was the model of the ImageNet. So if in top 5, if the correct class is there, then it is considered as correct prediction. But here you can see it clearly says that the given image is an horse. But you can ask me that given image also has a person, but in classification, this image was labeled as horse. Okay, so this is giving the output called horse. Person was not in this data set currently, which I am showing to you. So what is the first step? Get your data ready. From where data will come? From two sources. Okay, it will come either from prepared built-in libraries provided by deep learning framework, or you will create your own data set. You will create your own data set. Is that clear? Uh, can I ask Afsha to ask what is her doubt? Okay. So first we have prepared the data, or we have taken the data from the library, available library. Second, we have developed our own CNN or the neural network architecture, or we have picked a pre-trained model. Okay, this picking up a pre-trained model is called transfer learning, will be discussed in subsequent session. So when you build your CNN, you need to set up many parameters. Okay, like which loss function to use, which optimizer to use, which activation function to use, how to build a training loop. All this is required for training your model. Okay, so once you set these hyperparameters, okay, once you set your hyperparameters, you can do that actual training. Okay, basically what actual training is, it will learn from the data and adjust the parameters of each neuron that you see in the neural network. Some may be activated, some may be deactivated based on the type of learning. So the outermost layer is a input layer. This is an input layer, and the last will be the output layer. Okay. So the first is to get the data. Second is to design a network architecture or select the network architecture. Third is to do the training. Fourth is to perform the evaluation of the model, how good it is. After identifying the problems, you need to improvise the uh, model by either changing the data, bringing out uh, more samples for the particular class for which it didn't learn properly, or changing the network architecture, changing the network architecture, or optimizing the parameters, means changing these parameters, number of epochs, number of batches, anything that cannot be learned automatically, those things are called hyperparameters. Those things are called hyperparameters. Okay. So once you improve this model through an iteration, through the benchmarking of the different models, then you will select one model, okay, and use that for the inference, or you will deploy that into actual production, okay, where the model is being used. Okay, so basically you save the model that you have trained, and you will reload the model for inference, means it go for deployment. So how this cycle is managed, like in computer science, we have the DevOps. To develop this cycle, we call it MLOps, which will be introduced in the 12th session, inshallah. Okay, so now uh, any doubt in these 6 steps, you can ask me the questions. If you have any concerns, you can ask me.
So
Brother,
how to select the hyperparameters?
a very good question. Basically, it will depend on the combination of type of data you are getting and the type of network you are selecting. Are you understanding me? Means my data is, say, medical image, gray images. Now, ImageNet is trained for RGB images, pre-trained model. So it may not give very optimal results for you, even though you train for large epochs or do something. So what you need to do is, you need to find out what is suitable parameters for you. This is usually for a specific data set. This will become a very big study called empirical study. Only fine tuning this parameter and finding out these are the suitable parameters and these are the suitable network architectures for this type of data. Identifying this can give you Q1 paper. As I told you already, hyperparameters means I cannot learn it automatically. So can you do some automation for that? Yes, we can do some automation so that it will change the parameters and develop various models. That process is called ML ops. And the framework, which is very popular coming nowadays, if you are looking for this job, you can look for a framework called AutoML. Okay. So here, if you see, the hyperparameter tuning is one of the important tasks. So if you see here, some of my paper, I'm trying to highlight. Okay, this is basically an empirical study. It is an study of identifying suitable parameters for a autistic phase of the children. I hope the answer is clear. Can I proceed further? Any other question?
Yes, sir. One more question, if you don't mind. Like
Yeah,
you
sure.
said that when we are using pre-trained models, we can freeze the lower layers and we can use only upper layers. We can modify it.
Yeah.
So how do we know that like which layer can be modified, or if we want to add extra layers, where to add? How will get to know? Like how will it help us in improving the optimization or performance?
Okay, I will use a certain statistic now saying that my network has 10 layer deep. Okay, madam.
Yes, sir.
Okay, out of this 10 layer, the layer 1 is an input layer. Okay, layer 10 is an output layer. Clear? So how many layers are remaining? 8 layers are remaining. Am I right?
Yes.
Okay. So in this 8 layers, when you do the training for some other task, for example, this network was trained for ImageNet, 1,000 classes. You want only 5 classes now. Assume this is trained for 1,000 classes, means it can how many output layer neurons will be there? 1,000, because output layer is 1,000 classes. Now I want to convert this into cat and dog. So definitely my output layer should be changed from 1,000 to 2. Are you following me?
Yes, it should
Okay.
be binary classification.
Yeah, yeah. No, you take it 3 if you don't want to confuse. Keep the problem multi-class problem only. Okay, take any 3 classes. Okay, now instead of 1,000, my output layer should be changed to 3 neurons. Am I right? Because my output layer is having 3 outputs possible. This is called uh, uh, changing the output layer. In between, out of 8 layers, I can try fixing 6, 7, 5, 3 based on the type of data I already have. So when I should do this type of freezing, when I have less data for my specific class and still I want more powerful deep learning classifier. So already ImageNet has learned lot of things to extract the classes, extract the features. Sorry, not the classes, extract the features. So when I freeze, say out of n layers, okay, n minus 3 layers means only 2 layers will be trained now, and the final layer will be just a prediction layer. You got my point, madam?
Yes, sir. Got it, sir. Got it.
Okay.
Thank you.
So how much to freeze, how much data I have, again is subjective to the situation. You got my point, madam?
Yes, sir. Perfect.
Okay. And any other thing?
No, as of now, no, sir. Thank you very much.
Any other one? Any other person has a question on this process? Because this process is very important. Whatever code you develop will be related to this only.
Hello, sir.
Yes, madam. Please
Uh,
proceed.
Sir, if I want to do the face detection, then ImageNet is not the proper network.
ImageNet is not a network. ImageNet is a data set, madam.
Yes, sir,
Using
but whenever we are using the transfer learning,
uh,
so we got that pre-trained data set, na?
pre-trained data set, if you are doing the transfer learning, very good, correct. Okay,
Yeah.
now may I know your exact question, please?
Yes, sir. So if I'm using face detection problem, so can I use that ImageNet data set? Because as of now we have seen that there are only 5 classes or 1000 classes, related to images like truck, then whatever horse, likewise.
Okay,
So
okay.
is it yeah? So is it possible to do the face detections by using that ImageNet dataset?
Uh, so again, I think your confusion is uh, there is something called image nets. Okay, there is some okay, and there is something called what you say. Let me just go to my file and open it because I will tell you the what confusion you are having. Okay, on ImageNet, there are different CNN architecture which have been trained and become the champion, like AlexNet, GoogleNet,
Okay.
GGNet, ResNet. So these are networks, madam. And
Okay. Okay.
ImageNet itself is a data set.
Okay.
So suppose I want to use a BGGNet for my face detection.
Mhm.
So I will be using a pre-trained model from ImageNet, but my data set will be images of the faces. Each person will be a separate class. Suppose I am taking 100 people data set, then 100 classes will be there. My output layer will be 100 class. Now
Yes, sir.
I will
Mhm.
retrain, but the initial parameters of this network will not be random, will be taken from the ImageNet. Did you
Yes, sir.
get my
Got
point?
it, sir. Yes,
Okay.
sir. Got it. Got it.
So there is something ImageNet dataset. There is something
Mm.
called ImageNet winner network architectures. So when you do the pre transfer learning, you will select one
Mhm.
of these existing model which is already trained on ImageNet.
ImageNet. Yes.
So basically, what is that model file? Then you have the network architecture. In through that network architecture, your all new data will be passed during the training, and new parameter will be updated for your network to recognize the faces. Am I right?
Okay.
Am I up to the point that you what you asked actually?
Yes, sir.
Madam?
Yes, sir. I cleared that. So that is the data set on which different networks are uh, built, VGG and all this AlexNet
Okay.
and
We
got
will
it, sir.
see them in more detail further. Don't
Mm.
worry, madam. Okay. If
Yes,
still you
got
are
it.
having a confusion, then you will see in action. Definitely, you will feel at ease. Okay. We will get to know them better. So now, uh, for everything, whichever library you are using, depending upon that, you need to identify the classes and the functions for doing that task. Are you following me? So if you are planning to develop a deep learning network model, okay, the only thing if you use the different deep learning framework, these things will change, but this task will be there. So if you want to use the keras, you need to identify how to load data set and how to create a data loader using keras. Okay. If you are using TensorFlow, you need to define how to build a neural network using a TensorFlow. So here, because I'm focusing on PyTorch, so these are the these are the packages that we use for doing this task. So for making the data ready, we use the transforms to do the transforming of the data from a image format to a tensor format. Then if we are using any of the built-in data set, we may be using a package called dataset, which is available in Torch, utilities, utility data package, and data package. So basically, each dot tells which package or the sub package you are using. So basically, if you see, there are two things that we need to have to run this. One is a Torch library need to be installed. Another is Torch Vision library need to be installed. Any doubt here? Okay. So if you are building a network, you basically using the packages called torch.nn, nn.module, and models. If you are using existing models, you will select the models from the Torch Vision models package library. Okay. If you want to change the optimizers and other things, you will be using torch.optim package. Okay. Similarly, you will be developing a loop. Then you are using a torch metric to perform the evaluation of the models. Then you will improve through the experimentation using the torch.utils.tensorboard. Okay. So TensorBoard is a very sophisticated package, which if you have the proper output of your uh, project saved for multiple models, it can benchmark and show you the various kind of graphs and visualizations through which you can easily identify which model to be selected for the given task, or which one is the best model for which use case you will identify. So basically, these are the packages or the libraries that we need to learn to build our CNN or deep learning network. So CNN is one of the network. It's not the only network. Try to understand this. We have neural network, then we have feed forward neural network, then we have back propagation, then we have CNN. Then beyond CNN, there are many things also that everything cannot be covered now, but we can have the better start for now. So here, for better understanding, I have given all the details like what is a neural network, what is a back propagation, what is a feed for a neural network, okay, what is the principle of convolution, how convolution work in practice, how to build a CNN, and then what is normalization, dropout, augmentation, and custom dataset. So when you reach custom dataset, basically you got the capability to develop your own research or your own new task model. Okay, so let me focus here. Just reload this. I think I have some issue with this file. Let me check it out. Give me a second. Okay, basically, we have the loading the data, preparing a data. Currently, we will be loading a data from a built-in library called Fashion YMNIST. Then we will prepare a data that we use the data loader for that. Then we are going to have a model 0, then model 1, okay, and comparing our models. So right now, actually, there is something called CNN calculator. Okay, so this is a calculator we use how to design a what you say, our CNN. Okay, now CNN lookup. Actually, I have organized these links, but somehow it was okay. So now first thing that we need to check whether we have the NVIDIA or not. So last class I have told you that exclamation is for the command. So basically the system, when you use the Google Colab, you are using the you are using the Linux based system. If you are using a Google Colab, okay, here you can use any of the command that we use in the Linux system. So by default, where you are working, what you are working, everything can be determined using the Linux commands. Okay, so if you want to change a directory to your Google Drive, you can write cd and then give your directory name. Okay, so now I need to check what NVIDIA I'm using. So for that, the command is NVIDIA SMI. So it will tell you which version of CUDA you are using. Okay, what is the GPU, what is its capabilities, how much memory it provides, okay, and who is using this GPU, all that. So if you want to check what torch version you are having, basically this is the command torch dot underscore underscore version underscore underscore, and which torch vision library you are using, torch vision dot version, it comes with underscore. So first we need to import torch for Pytorch library, because we have to create our own CNN. We use the NN module or the torch NN. Okay, then we have the use the data set. We are using a torch vision and torch vision data set, because we need to transform the data into a particular format to load into the tensors. We are using the transform function. Okay, matplotlib basically I'm using for image visualization. Okay, now when I run this command, okay, so it will be if there is okay, what is the mistake? Somehow it got deleted. Okay, so now currently I am using a Pytorch version 2.3 with CUDA 11.8 as in my environment. Okay, here you saw the CUDA version 12.2, right? This is on system level. This is on my Anaconda environment. I can try different CUDA versions. If I have to change this, I need to go and do the pip install with a new torch version library for a new CUDA one. Okay, so now I'm going to use a CIFAR 10 dataset. Basically, it consists of 60,000 images. Each image is of 32 by 32, and it is a color image, and it has 10 classes. It has, each class has 6,000 images. Means it is perfectly balanced data set. Means each class has same representation. Usually it will not be the same. For example, you are doing medical segmentation. There are six type of tumors or the disease, but one or two types are very rare, so you don't get more samples for them, so you get imbalanced data set. That is a different issue in deep learning, that we need to handle imbalances in the data set. Means it will get biased. For example, Chinese people data set will be performing very good on Asians, but will be performing poor on Africans. So this is also a special task of the deep learning. We call bias, algorithmic bias. So you need to know the biases that you will create during your learning. So if you have a very modest balanced data set, then this is the one of the best thing that you can do. But if you are using the person data set, different demographics cannot be having in a similar representation in your data set, then the demographics which are represented heavily, for that your network will learn good, very well. For the other, it may not learn well. So for that data imbalances, you need to manage it through different other techniques also, that we'll be discussing later. So from where I can get this data set? From the Torch Vision dataset library. So how to get this? I have to invoke the function called Torch Vision dataset cifar. So right now I have actually, when I have previously executed, I have downloaded the data set, but I have removed it right now from my current directory. Okay, currently data is not there. So first time when you run this, okay, so this function has these many variables. Root, where the what will be the data folder name. Okay, okay, do you want the split for training or test split? That you can specify. If the data set is not available, you want to download or not, that also you can specify. If you want to transform, how to transform the data, that also you can specify. Okay, so currently if you see my code, I have created a transformer to normalize all the images, so that RGB color skew of each image will not make an impact, and load it to the tensor. So there are two functions in my transformation. Means when I take the data and load into the tensor, I do two things. I will normalize each image. Normalization is a technique to get rid of imbalances of the color pixels, and I need to load it into a GPU so that it will work faster. Okay, so the data set comes from data set of the Torch Vision, which I already imported. The data set I'm going to use is CIFAR 10, where I'm going to download it in a directory called data. So right now, can you see any directory here named data? Yes, no, please tell me. Hello? Anybody is there?
Yes, sir.
Okay, thank you. You cannot see any directory right now data, but when I say download as true, if it is not there, it will do the download automatically. So let me execute this code.
Okay.
So right now,
About the video data set, how we can, if we have a data set in a video form.
okay. So what is a video? Video is nothing but pictures in motion, right? It's frame after frame.
Exactly.
Okay, there are two ways to deal with videos. One is you uh, extract the frames. For example, you are doing action recognition. So action cannot be identified from single frame. Am I right? Yes or no, madam? Can you
Yes, sir.
identify what is an action from a single image? Whether I'm doing a handshake or slap, you cannot identify from a single image. You require sequence of images, right? So
Yes.
you need to have the memory from previous frame to next frame. For that, we have some special neural network architecture which remembers what happened in previous frame. This is a one method. Second is you compress, you make a batch of all the frames as one input and redesign the CNN as 3D CNN. Currently, I'm not dealing with 3D CNN, but you can make a 3D CNN and give all the set of what you say frames as one input to the 3D CNN. Okay, madam, are you clear with what you're supposed to do? You need to use the special architecture where one sequence remembers the previous frame output. Means it will be decided based on certain number of series of outputs. Okay, so currently it is downloading, and what you are able to see here is the amount of bytes this data is and amount of time it will take. Okay, depending upon the network, it may take a various time. Okay, so right now what I do is I just interrupt this kernel. Okay, because it's taking around 20 minutes, which is not a feasible time to proceed. Okay, so at the end, if you see here, the data folder is created and data is getting downloaded, right? So I will replace this with my already downloaded data. Did I serve your answer, madam? Or you have any more query related to video? Hello?
Madam, you can answer.
The question was how to handle the video. Handling video are two methods: extract frame and design a neural network which has a memory, okay, of a previous frame. This is our first method. Second method, translate the CNN into such that it will take all the frames at once to recognize the video or video action. Okay. Or another method, you work on frames only with a normal 2D CNN architecture, then do the tracking and define the actions. So have you seen the difference when I copy the data? Because already data is downloaded and available, it will say the files already downloaded and verified. If you are running in Google Colab, it will take less than 5 minutes because it will be very fast on Google Colab, because Google Colab is a high performance computing platform provided by Google Cloud platforms. Okay. It is working on Google Cloud platforms and it is going to be very powerful. So now, where is my data? My data is in the name called test data. My entire data set is downloaded in a variable called test data. Now let me see what is there in this data. Okay. So what I do, I copy the data called test data and train data both. So train data, because I have given the Boolean split, train equal to true. Okay, here train equal to false. Means here what data is added is non-training data. Here what data is added is only training data. So basically when I write train equal to false, I am getting the test data set. So I have two data variables, train data and test data. So if I see the image, it is a tensor of rank 3. So what is a tensor? Tensor is a mathematical notion or a representation of the matrices or higher order data structure. Is that clear, madam? So why it is rank 3? Because it has a 3 channels. R channel, this is a values of R channel. This is a value of green channel. And this is value of B channel. And so forth and so on. So what is the shape of this data? You can see that this data is a rank 3 data. Okay, this is the output, my output. It's the rank 3 data of a rank 3 tensor with the order of 3, 32, 32. What does it mean? 32, 32 is an image because it has a 3 channel. It is having a color code, RGB channels. So the shape of an image tensor is 3, 32, 32. Whereas 3 refers to color channel. This 32 refers to height of the image. This 32 refers to width of the image. Okay, so basically we took this fashion net sample, okay, and we to transform it and provide this as an input. Okay, so our input will be of this type. If color channel is equal to 3, the image comes in pixel value of red, green, blue. Okay, if the order of the current tensor is not referred to as CHW, color channel height and width, then there is a debate on whether image should be represented as CHW or HWC. Okay, so that debate I don't want to go into detail. But now let me check how many samples are there. How many samples are there? I have the train data samples 50,000. Okay, I have the labels for this data. Targets are nothing but our labels based on which we learn what this data is. Okay, and 10,000 are testing samples. So this is 50,000 training images and training labels. 10,000 testing images and testing labels. Okay, what are the names of the classes that are available? These are the 10 classes that are available in our CFAR 10. Okay, so aeroplane, automobile, bird, cat, deer, dog, frog, horse, sheep, and truck. Okay, now how to prepare a data holder? So what is data loader for? So currently what we have done, we have taken a data from the library resource repository, downloaded it into our local machine, then we transformed it into the tensors. Now who will consume this? Our training algorithm. How it will use it in the form of batches, in the form of batches with help of data loader. So we create a batches or mini batches. So what is a batch? It is again a hyperparameter. In a one go, how many images we will feed to the network. Okay, so here we consider the value as 4 for simplicity, because if you have low capacity GPU, you cannot run high batches. Or if you have high capacity GPU also, for high number of batches, you may require more time, training time for each epoch. This you can change later when you are practicing and try. So right now what I'm doing, I'm creating a data loader with a batch size 4 that I'm going to train a data, take a data from a training data and provide a train data loader, and test data and provide a test data loader. So shuffle is true in every epoch for the training, but for testing we have not done it because it's not necessary to shuffle the testing data. Okay, because testing will be done in all the test data, so the order will not matter. So if you see currently the data loader objects have been created. Okay, the length of a train data loader is 12,500, but of how many batches? 4. So 12,500 into 4 is how much? How much? How much data we have in training?
50,000.
50,000, correct. So basically we have divided 50,000 data into 4 batches. Each batch will be of 12,500. So usually when we create the batches, we use the power of 2. Means bits like 2, 4, 8, 16, 32, something like that. Okay, usually we try to use the avoid non power 2 bit values. Okay, but sometime in some cases you can still use like 6 or 10 value also possible, but it's better to use the batch size in power of 2, like uh, 2 at position 1, 2 at position 2 means batch 2, 4. If you have very low power GPU or CPU and you want to train, you can make the batch size 1. Okay. So what you need to focus right now is the syntax of this code. Okay. So if uh, till now, which portion we are doing out of 6 steps till data loader is the step 1. Okay. Currently we have done transform, means download the data from a data set, transform it, load it to the tensors, then use the data loader so that it can be uh, used for the training. Okay, now we are ready. Now go for the CNN or the neural network that you want to train. So currently in our simple this, we just want to visualize our data. What is the shape of our data? Okay, of each batch is 4 images of type 3 into 32 into 32. So because these are 4 ordered data, this is called rank 4 tensor. Image was a rank 3 tensor. Your scalar value will be rank 1 tensor. Okay. So tensor is an uh, representation of the data that we are using. Okay, so if you want to visualize this image of this batch, you can just run. You can see I have, because it's a low resolution 32 by 32, you may not able to see very clearly, but when it is reduced, okay, you may able to uh, get the idea. So basically, why these images are so low resolution? Because we want to save the training cost, training time, all that. Okay, so do we need to use such a low resolution, or you can use an high resolution? You can use an high resolution, but your training time will increase. Okay, that you should remember. Okay, and your data loader, transformer, transform function, everything will change based on the size of your input images that you are going to use. Okay, so usually for face recognition, we don't go for such a small resolution. We stick to like 232 or 264, something like that for the images. So images will be clear. So basically these are the labels and these are the images. So this is a truck image and this is a frog image. So basically these are the some of the classes that we have already. So this is a show image function. We have converted the image, taken the image and represented into a numpy array, and then use the plot.show to show the data. The same thing, if I use only image, it will show the matrix like I've shown you before. Okay. Good. So any question on mini batches? Why we create batches? Can anyone answer why we create batches? 。 Uh, there is a question on any other model other than 3D CNN for action recognition. Yes, there are different architectures that have been already in place for action recognition. Okay, you can find some latest review paper for identifying exactly what are the different techniques used in action recognition. Okay, so I think my kernel is reset or is active. So if my kernel is reset, I may get an error. Okay, it's not giving error means it's active. Kernel means the connection of my Jupyter notebook. Okay, so here we have used the NumPy library to show the image. Okay, now we are using the simple network, simple flattening of the entire what do you say input. So what is our input? What is our input size? 32 by 32. Okay, so 32 by 32 into 3, how much it will be? 1000. Okay, 3072. So these will be the number of input parameters in a flattened network. So we are building a simple model, a flattened network. So here we are building a baseline model using NN module. A baseline model is one of the simplest model you can imagine. Okay, it will be consist of linear layers. So we are doing the flattening of the this batch. So our batch size will become 1024 into 3. 1024 into 3 is nothing but 1024 into 3 is nothing but 3072 only. Okay, 3072. So how many parameters will be there in our input layer? These many. Okay, so here we have created a simple channel height width. So channel is 3, height and width are 32. So after flattening, we got the image of 1024. So now we are creating our class where we are going to create a network. So this network is basically having flattening layer to take the input. Okay, then it has designed with several linear layers. So our feed forward network will be having flattening, linear and linear 3. Currently I have disabled the linear 2. So this is my class for my CNN. Now what is my class name? CIFAR 10 model V0. Okay, class 10 model V0. So input shape is 1024. Hidden units are 10. Okay, now we want to take the input shape. What is the input shape? We are writing 1024 into 3 is equal to 3072. You can try different configurations also, that is possible. So now we are reducing 3000. So our first input neuron layer will have 3072 parameters. 3072 parameters, each for 1 pixel of an RGB image of type 3 into 32 into 32. So total, when I convert this into number of pixels, my input layer has how many neurons? 3072. From 3072, my first hidden layer will have 128. Second hidden layer will have 64. And this, my output shape, will be the output layer or fully connected layer. So now if you see my model, this is the architecture of my model. So my model is basically having a input layer which is having 3072 neurons. It will be converted into 128 neurons. This 128 neurons will be converted into 10 output. Okay, why it is not having 64 here? Because I have disabled this. Means my earlier hidden layer 2 was not enabled. So now when I do this, now you can see the summary of my model. After 128, it should be reduced to 64. From 64, it should be reduced to 10. What is happening? Any issue here? X. Okay, X is an output of previous layer. Okay, shape to unit 1, unit 1 to unit 2, unit 2 to shape, output shape. Okay, let me update it. '56, 57, 58. How is my network is defined? Linear input shape 3072, hidden unit 128, 128 to 64, 64 to 10. This should be the expected output. Flatten one, linear one, linear one. It's not taking linear 2. It's not taking linear 2. Okay, let me, I'm short of time. I will get back to you with the solved solution for this. Okay, so basically you should understand this is how you can design the neural network, okay, using the torch. Okay, so this will tell you how many megabytes and how many total trainable parameters. So you have decided only just 3 layers. Okay, this is your neural network architecture. Okay, output input layer 3072, then input to hidden transformation, hidden to output transformation. It is having how many neurons? Just think. Can you read it? 400, then 2000, 890 parameters. So just imagine if you make it 100 layer, okay, how it will be, how big it will be. So we call it deep learning when we have more than 3 hidden layers generally. Okay, okay, then we call it parameter. So now we set the optimizer and we try to load it to the GPU. Okay, so basically CUDA 0 means our first GPU. Okay, if GPU is not available, it will run using CPU. If you are using the CPU, then it will be very slow. Okay, so finally you need to develop a training loop. Basically, I'm writing a for loop and provide all the batches one by one using loss backward function. Okay, and then calculate the accuracy after each loss, each epoch, and uh, report the accuracy. So when I have to set a hyperparameter here, training number of epochs. Okay, so here by default the epoch value is set to 10. So now our training loop is function is ready. Means this is going to do the third thing. What is this? Fitting, model fitting. Okay, and model fitting loop. So what is this? This is the second part, designing the loss optimizer and the neural network. Okay, the third part is uh, training, setting the training loop. Okay, and start the training. Okay, certain JavaScript error is there, but currently my model is running. So my model will be doing the training and it will report all the loss and accuracy. If you want to see it, it will be something like this. Okay. So if you are running it in Google Colab, it should be little fast because you will get a better GPU there. Okay, so okay, very good answer. Why we require a batches. So depending upon the uh, GPU, it will take certain time. Currently, I have not shown the progress, so you don't see the real-time output here. But in the subsequent notebooks, we have done the proper management to show the progress. Okay. So once you got the history of all the epochs, this is what accuracy you got in each epoch and training and validation, and what was the losses. This is history. So basically this training and validation loss and training and validation accuracy. Basically you reach the accuracy up to 61% and validation accuracy around 50.9%. So if you plot the training, this is a loss graph. So it started from 1.6 and came to 1.0. The validation remains 1.5 to 1.4 only. Okay, so here you can see the validation loss is the orange line, which doesn't decrease along with the blue line. The best training parameters can be decided. Someone asked, right, how I can understand what parameters are good. The parameters are good if the loss, it should be like L-shaped loss, and your orange and blue line remain close, training loss and validation loss, and similarly your training and validation remain same. If your validation accuracy is too low, then basically your training is overfitting. Okay. So once the model is ready, you can load the model. Okay. And run the see the images. Okay. So anyone is running the training and running successfully on the Google Colab? Can you tell me? Okay, and the question is, what is the difference between testing and validation? Okay, so basically, when we do the splitting, we can split into three parts. Okay, one is training, validation, and testing. Okay, the test data set will be taking the data for benchmarking the two different models, whereas validation is being used to check how the performance is being updated of the model due between the two epochs. I hope the point is served. Okay, so basically, when I want to say which model is good, I will use some test data set and say that on test data set, this is this. Okay, basically what for validation data is used? Validation data is used to update the model parameters. Means it is used during the training. It is used during the training. The test data, when you do the testing of the data set, you don't go and update the model. I hope my clarification is served. If you have not understood, you can, or if you have any further question, you can ask me further.
Excuse me, sir.
Yes.
Sir, in training, what will happen? In validation, what will happen, sir? How training and validation two are different? How exactly?
Okay.
Because in training,
Imagine I'm
yeah,
training I have given a data image of a
yeah,
dog, of a
yeah,
dog.
yes,
Okay.
sir. Okay.
So when I have given the data image of a dog, okay, during the training, what is the label for the dog? Dog should be 0.999 something, means,
Yeah.
or 1. But what you predicted is zero point 0.6 as a dog. Dog has a 60% confidence. So this 1 minus 6 means 0.99 minus 0.6 is your loss. You got my point? So
Yes, sir.
like
Yes, sir.
this, you have done the full epoch.
Yeah.
Okay, like this, you have done the full epoch. After epoch, how good this epoch model is evaluated using validation data set.
Okay. Okay. Okay, sir. Fine. Fine.
How good the final model is evaluated usually on test data set. You
Okay.
train for
But
100.
that means during training also we'll use validation data. During testing also we'll use validation data.
No, you can keep both data set same, validation
Yeah.
and test, but that will not reflect any good. So if you
Okay.
divide in 3, it will be very good.
Okay.
So
Okay.
to get a validation of different batches in a
Mm.
different sequence, so that entire data is used, not only the separate validation data, there is
Mm.
something called k-fold validation.
Mm-hmm.
There is something called k-fold.
Careful.
K-fold validation means you will not you will use one. For example, you divided your data set into 8 parts.
Yeah.
Sorry, 10 parts. 9 parts you will use for training, and
Yeah.
1 part randomly you will select for validation.
Okay.
Validation data set is not fixed.
Okay,
Means
sir.
you
Mm.
use every part for the validation during the training of the model. So it makes some robust model with a less data.
Okay.
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 So
If the model doesn't perform as expected during validation, then model parameters will be again changed or modified. No, sir. Accordingly.
uh, Can you pardon? Repeat your question,
If
please.
the model doesn't perform as expected,
Okay.
then the parameters of the model will be adjusted during validation.
Do you see this loop is when running, right? All the
Yes.
10 epochs will be running consecutively. You
Yeah.
will not interrupt the training.
Yeah.
Okay. So,
Okay.
so nothing is getting updated automatically here.
Sir.
Okay. Let me open from a Google Drive the main file. Okay. Because my file got changed a little. So I want to show you the output of a previous execution because it's taking some time on my local PC. I have not anticipated it to be like this because it was behaved differently during the my testing, personal testing. So let me open the original file. Okay. So this loop will see uh, this loop will repeat for all the test data loader. The currently our test data loader is nothing but the validation loop. Okay. Model.eval is where we actually fix up the things. Okay. Currently, no, I went to model 2, I think. Let it be model 1 first. Okay. So if you see the output, all the loops will be consecutively happening. This is happening internally. Okay. So best accuracy of the model will be reported at the end. Okay. So if you have the epochs, you will get the epoch output something like this. So how much time it took? Around 32 seconds. Okay. What is an accuracy you got? This accuracy. Okay. This is validation accuracy and validation loss. Okay. This is training accuracy and training loss. Are you following me? So your validation will be updating the next epoch model based on this. So suppose in next epoch training, I got the loss more. So my best save will not be done the save. It will continue for the next epoch. Are you following me? So finally, I will get the best model saved. That is at the end of the complete training. Fine. So with this, let me, I have just 7 minutes to um, cover up. So now I just want to introduce what we have provided you. So we have given you the complete explanation of what is deep learning, what is linear classifier. Basically, linear classifier is nothing but a like a line equation, which is nothing but a neuron, a neural network. Y is equal to wx plus b. Okay, so this linear classifier will be adjusted on the data. Okay, why we require deep neural network? Because of a non-linearity of the data. You cannot find the data set in real world like this separable. They are not linearly separable all the time. So we require a non-linearity. Okay, for non-linearity, what is a special technique we use apart from the what you say convolution network and other things? We use something called gradient descent. Gradient descent basically do the optimization. It optimizes the loss. Okay, it optimizes the loss. Then we have started with a simple neural network. How to design a simple neural network. Okay, So basically, this is an input. This are the transformation is nothing but wx plus y plus b. Okay, so it is nothing but this equation. This is how we can do the calculation. Understand? So after this, what is backpropagation for a neural network is done. Then we come to the principle of convolution. So why we require convolution? So if you are from the pattern recognition or image processing background, you have heard about kernels and filters a lot. Am I right? So basically what these kernels or filters will help us to do, they try to help us to extract the features. They try to help us to extract the features. So these kernels or the filters used to be fixed. Like you used to design a particular filter or a kernel design for a filtering the features, or that process is called feature extraction. So now here neural network itself is extracting the features. So I've shown you the neural network output. So this is like extracting the features. Okay, so there are different type of layers like convolution layer, then pooling layers, activation functions. Okay, then like ReLU or some activation is used. Finally, these features are being mapped to a output, particular output. So how this is being done? By automatically learning what type of filter to be set. That is the power of a convolution network. Instead of we specifying what should be the filters for extracting features, it will learn them automatically and decide what part of the neurons should be activated or not activated, what path connection should be followed. That will be done. So basically, you can see this is a one input. This is one convolution kernel. Okay, so and this is the output happening. So how this is being done? Basically, we have the width and height, number of channels, then we have a filter count. Then if you have the stride is the amount you move the kernel. Okay, like if it is moving one by one, then it is called one stride. If it has appended the zero around the input, then that is called padding. So the complete material to follow up to the custom training is given to you. Okay, so now the open floor is open to you. If you have any queries, please feel free to ask. Okay, the 6 steps remain same. Only thing what is changing is how you are getting data, how you are initializing the network, and how you are doing the training. So training parameters will change, and that makes the network uh, very different. Okay, so now the floor is open for question and answers.
Excuse me, sir.
Yes.
Sir, the basically mini batching is done only for optimization, sir.
Basically, yes, batching, mini batching.
The samples will be huge, heavy samples will be there. So if you make it into batches, so it is used for optimization, sir.
Basically, all hyperparameters will optimize my network or model.
Yeah.
Okay, so batches is one of the hyperparameter. You understand my point, sir?
Yes, sir. Sir, is there any criteria to decide, sir, number of mini batches? Like,
basically, if you are doing research or the development, you will find out what the experts of the field have used for this type of data or this type of network.
okay,
If
sir, fine.
if you don't have that template, that is
Yes,
open research. Means
yeah.
nobody have that answer that you are asking me.
Yes,
Understand?
yes, sir. I do understand, because even in the filters also, the size or number of filters, how to decide that also, like many experts have used. Based on that only we can like hyperparameter we can set. Number
Okay.
of filters or the kernels.
Basically, if you see my CNN, how to build CNN, there
Yes, sir.
you can see how I have taken the notes. Then
Yes.
actually in full day workshops, we
Yes, sir.
use the CNN calculator, make our own CNN.
Oh, okay, sir.
Okay,
Thanks.
so
Yes.
everything is given. it is self-explanatory. Only
Ah,
thing is you need to have patience to run and learn.
yes, sir. Yes.
Okay, so
Sure.
can you tell me what is a CNN I have designed? Okay, I will take whatever input. Basically, I
Yeah.
have decided a convolution layer
Yeah.
of kernel size this and strike this. Okay, then
Okay.
I have the max pooling layer. Then again, I
Mm.
have the convolution layer. Then I have three linear layers, one activation function. So how this is being arranged in this form? So I use Cono 1. This is Cono 1. Then Cono 2. So two convolution layer. Then I have ReLU. Okay, and then I have ReLU. Then I have fully connected layer. So this becomes my feed forward network. So how to get this value is depend on this calculator.
Sir, this loss what we are finding, is it only for the label data set, sir? The loss what we get now, the model when we train the model,
Yeah,
is
yeah.
it only for the label data set, sir?
The loss or the optimization will be different based on the learning. If you are
Yeah.
doing reinforcement learning, then loss is different.
Ah, yes, sir. The
If you
RNN.
are doing regression, what is the loss? Your actual nose of the tip of the nose was suppose pixel number 8,8. You calculated it 10,10. Okay, means pixel
Okay.
number 10,10. So this difference now cannot be calculated loss like prediction. It will be taken in terms of root mean square error.
Yeah. Yes, sir.
Okay, so the
Okay.
loss functions will be different for different type of learning.
Okay, sir. Okay, sir. Okay, sir. Understood, sir.
Okay.
Thanks, sir. Thanks a lot, sir. Thanks very much.
Okay, so
Yes.
I request all of you to go through the material. This is the concise, the full package to start with. Wherever you have the problem, errors, or not able to understand, please open a thread in chat groups. Okay,
Okay,
and
sir.
help each other also. And we are also ready to help you. Then only we can build something meaningful. Okay,
Okay. Okay,
so
sir.
right
Thank you
now,
very much, sir. Thank you very much, sir.
right now all these sessions we are taking you to show our next analytic products and the applications. Our analytic part not started yet, but what it will be made up of all these things. Basically, we have deep learning, we have the Python programming, we have the NumPy, Panda, and Matplotlib. Then we usually use some neural network architecture or deep learning framework. Here, for an example, we have taken a Pytorch. Now, based on this, we have different network architectures, real-time architectures. The most of the popular video analytic architecture right now we are using is YOLO. Okay, and that also will be focusing on, and the YOLO applications also will be focusing on in coming sessions. So I request all of you to join on time and go through the material. Maybe I understand you may be having a lot of constraints. We will not be closing this chat group very soon, but I expect you to come out of this chat group as a separate, dedicated interest group so that we can collaborate and work further for future. Okay, thank you. That's all.
Sir,
Yes, sir.
uh,
Yes.
we have a few questions in the Q&A section. So would you be ready to answer them?
Yes, if you can just read for me.
Yeah. What is your opinion of using Julia instead of Python?
Okay, again, it's a debate. Okay, Julia is very well organized for HPC clusters and available to the specialized labs also. As I told you yesterday, that people have written off Python few years ago itself. Okay, so my answer is same. Like I have told you, why Python is going to stay longer, because lot of research beyond an human comprehension means, like when I started deep learning, I could have said you that I know 80% of deep learning arena or 90%. Now, if anybody claims that you know more than something or everything, it's a false claim. Every day, maybe hundreds or thousands of nets are being produced. Every day, the new techniques to improvise the detection or the recognition or the tracking is being produced. So all this is being basically done on PyTorch or Python. How suddenly you can have Julia replacing Python immediately? The amount of research right now in deep learning also got too much segmented. Like yesterday, when Prof. Hazrat Ali joined, he himself presented as only person for GAN, generative adversarial networks. He's not claiming anything about NLP. He's not claiming anything on vision transformers. Okay, so it is becoming segmented too much, and it is produced, knowledge is produced too rapidly in Python and Pytorch that it is not immediately possible to get it replaced by Julia. That is my say. Okay, it's debatable. Someone can defer to my opinion, but this is what we look in the research groups right now.
Thank you, sir. We have next question. How many frames we require to identify an action in a video?
Okay, it depends on quality of your image and speed of the action. For example, if you are analyzing some droplet flow or or car moving or a sports person with 5 frames per 5 frames per second, you cannot visualize it very well. So for such situation, we require high speed camera for droplet. Maybe we are using 5,000 frames per second high speed camera. Okay, so it depends on use case. Generally, for normal normal quality of video, suppose you have 16 or 32 frame per second video, then basically you want to optimize it to a smaller chunk. So as I told you about action recognition, what you say, question, same thing I want to tell here also. Based on your domain of recognition, video recognition, you need to find out what is an optimal frames need to be used for one action. So if you can identify the action with less number of frames, you are more better, means you have solved some problem. Anybody can say with more number of frames. If with less number of frames, if you can say, then you have developed a very good deep network technique, and definitely it can be very high throughput research. So generally we have seen 6 to 16 frames, okay, in action recognition.
Okay, sir. We have Professor Hussain, sir. He has raised his hand. Sir, do you have a question? Professor Hussain, sir. We have next person, Hira Nias. You can unmute and ask your question. Hira Nias. Okay. Mr. Satish Pise. Mr.
Yes, sir.
Satish, yeah, you can ask your question.
Sir, see, so I just got one problem statement in a hackathon. So this is the DRDO project. Actually, they want to identify the objects, okay, live objects with respective direction and speed. So how we can catch through the video analytics? Because see, guns are firing the bullets, and our objective is to catch that bullet and identify the respective speed how much it is, and which direction it is going. So this is a basic scenario related to that.
Okay, sir, very good and interesting research you have highlighted. There is something special research area called small object detections. Okay, because your bullet is very small projectile. Am I right? Sometime with a naked eye, it may not be even possible to see it. So if you see on Google, YouTube, those who have done the reviews on weapons, they use, as I told you, high speed cameras, then show you the bullet in slow motion. So first ecosystem required here is a camera to capture that projectile. If it would have been shell like Canon shell, or if it would have been any other projectile, it would have been easier with normal camera and normal frame per second. But here in this, the first thing that we require is a type of uh, camera that we should use to capture this kind of images. Then comes the data design. Okay, so what kind of bullets, what different types of bullet, what is 16 mm, 32 mm bullet, what is .32 bullet, what is .8 revolver, all that you need to consider, and you need to have the data for them. Then comes the neural architecture to be selected. Okay, so if you have the capture mechanism, definitely we can solve this problem. So if you have zoom camera along with the high speed camera, then definitely you can magnify the projectile also. So it's not a one step solution. It has, you need to attend all the 6 points to get this problem solved. So if DRDO has provided you any data set, then directly we can start on that without thinking other aspects that I have discussed right now. Okay, so you can try any, you can benchmark existing detection networks like fast RCNN, or some segmentation networks like UNet or SAM, or even you can look for a VLM networks also. But VLM networks will be very slow for inference on embedded devices. VLM means vision and language model combination. Very large vision and language model is called VVLM. So currently, all the research direction is in computer vision. And the latest topics are like diffusion models and VLMs. So if you really want to make a good review paper, you can think of a small object detection, then utilization of VLM for small object detection. That is my advice, sir.
I believe Satish sir has found his answer. We have.
Yes, thank you very much, sir.
Okay, thank you, sir. We have Mr. Zakir Hussain.
Sir, this is good evening, sir. This is regarding 3D image. I mean, the algorithms and the models and I mean, whatever fine tuning that we make for a 2D image model. I mean, can we apply the same model to a 3D image?
Very good, sir. Basically, my research was on 3D and 4D images during my previous tenure with the Center of Unmanned Technology. Basically, we have used the 4D data for driver drowsiness detection and 3D data for face recognition or the face parameters, face feature extraction. So basically, there are so many things here. Either you can go for 3D CNN, or you can go for point cloud networks, which can handle directly point cloud, raw 3D data. Or another famous popular method is you can see the paper called Learning from Million Images, okay, by Prof. Gilani. Okay, so
Yes.
basically they have extracted 2D features from 3D data and then perform the recognition. The more feature maps you extract from 3D data, means more information can be captured. So there are solution one, use the 2D CNN, convert 3D data into different feature maps and provide them as a one set of image
Yeah,
or
got
batch
it.
of image, or
Okay.
use the graph neural networks or point cloud networks. Okay, there is a
Okay.
very special neural network model called PointNet or
Okay.
PointNet plus plus, which is very effective in object detection in 3D point cloud.
Okay, so existing models, like I mean the 2D images model or the algorithm or whatever thing, are libraries. I mean, need to be upgraded or need to be updated, right? For the
No,
3D.
no, no, no. We can use it. But for example, from 3D phase, I can extract the depth map, combine it with some other feature like azimuth, elevation, etc.
Okay.
Okay. So I got the new image of 2D
Okay.
of three features, and I am giving depth map and this azimuth elevation as a
Okay.
three channel image of a
Okay.
3D data to a 2D network.
So, okay. Okay.
This is also
Okay.
possible.
Okay. So already it is there as a, I mean, the 2D libraries.
Yeah, 2D libraries means 2D networks handling the 3D data.
Okay.
Already solutions are there.
Okay.
Okay, there are 3D networks, there are point cloud networks, there are
Okay.
graph neural networks. So
Okay.
multiple methods are there in deep
Okay. Sir.
learning.
Okay, sir. Got it. Got it. Thank you, sir. Thank you.
And commonly in driving, when we use the point cloud LiDAR, we use the unsupervised cluster
Okay. Sir.
for recognizing the objects. We don't do the object detection using deep learning there
Okay.
because we require real-time feedback for the controller in the autonomous vehicle.
Okay, sir. Okay.
Welcome, sir.
Okay. Thank you.
Thank you, sir, for your wonderful session and really a practical implementation of the deep learning with various examples and the coding part, which really create an interest to build a new model for different applications. So
Okay.
we'll take it further to the tomorrow's session. So I would like to thank our the complete team. So thank you participants for joining the session, and please be on time tomorrow. We have a very good expert teams again for the same session. So for the same topic. So good night. Thank you.